let's put into practice the three Pythag identities that we talked about today. All three of these are actually on your formula sheet, so you don't have to memorize them, but you need to know when and how to use these Pythag identities. So example 25, part A, we're trying to simplify cos squared times tan squared theta. So let's write it down. So we have cos squared theta, tan squared theta. First thing we know that tan is sine over cosine, so we can replace tan squared with sine squared over cos squared. So that's the same as cos squared times sine squared over cos squared. Since we're using tan of theta is sine theta over cos theta. Now the cos squares on top and the cos squared on bottom can cancel. So we're left with just sine squared theta. And we're done for part A. For part B, let's have a look at how we do it. So for part B, we've got tan squared theta minus 1 over tan squared theta plus 1. Again, we can use the fact that tan is sine over cosine and replace tan squared. So on the top, we have sine squared over cos squared theta minus 1 all over sine squared over cos squared plus 1. And this is because we are using the fact that tan theta is sine theta over cos theta. And so next, to add or subtract fractions, we need to make sure they have the same denominator. So making the top, the numerator, the same denominator, we get sine squared minus cos squared all over cos squared. And on the bottom, we have sine squared theta plus cos squared theta all over cos squared. Now we're dividing fractions. We keep the top the same and then flip the second guy, the bottom guy. So we have sine squared theta minus cos squared theta all over cos squared from the numerator. And then we multiply and flip the bottom part, which we have cos squared over sine squared plus cos squared theta. Now the cos squares top and bottom can cancel. This one on the bottom is our Pythag identity. Sine squared plus cos squared equals 1. So that equals sine squared theta minus cos squared theta all over 1. Why? Because we are using the identity that sine squared plus cos squared theta equals to 1. Always make sure you're quoting which formula, which identity you are using. And so anything divided by 1 is itself, which we have sine squared theta minus cos squared theta. We can take it one step further, because from the Pythag identity that sine squared plus cos squared equals to 1, we can rearrange it to be cos squared theta equals 1 minus sine squared theta. So that's just rearranging the 1 from the top. If we can do that, then we can substitute the cos squared to be 1 minus sine squared theta. Expanding our brackets, we have 2 sine squared theta, because negative is positive, and we have minus 1. So this simplified becomes 2 sine squared minus 1.